In section 2.8, we're going to be discussing inverse functions. So we're going to use the inverse function property in this first example to determine if f and g are inverses of each other. Well, f is going to be 5 plus 3x. G is going to be the function x minus 5 over 3. To solve this, we need to show that f of g of x is equal to x for all x in the domain of f. And we also need to show that g of f of x is equal to x for all x in the range of f. So the first thing I want to notice here is that the domain and range of both f of x and g of x are R. It is all real numbers. So really, we just need to show that f of g of x is equal to x. So let's verify that. This is 5 plus 3 times, and we replace x with g of x. So this is x minus 5 over 3. 5 plus 3 times this quantity. 3 over 3 cancels, so this is really 5 plus x minus 5. The 5's cancel, and we get x. So far, we're looking good. Let's try g of f of x. G is x minus 5. Well, x gets replaced by f of x. So that's 5 plus 3x. Then we subtract 5, divide by 3. Well, the first thing that happens here, we have the numerator is 5 plus 3x minus 5. So we notice those 5's will cancel. So we in fact get 3x divided by 3. Now the 3's cancel, and we just get x. So in fact, we do get f of g of x is x, and g of f of x is x for all x in the domain of f for this first one, and in the range of f for the second one. So we are done. We have used the inverse function property to determine that f and g are inverses of each other. We're going to do one more example from this section, and that is to find the inverse of f of x is equal to 2 plus 4x divided by 1 minus 3x. To do this, we first write out y is equal to f of x, which is y is equal to 2 plus 4x divided by 1 minus 3x. So all we did was replace f of x with y here. Then we want to solve for x. Well, how do we do that? Well, we have 2 plus 4x over 1 minus 3x over on the right-hand side. We probably want to, or we do want to, put all of the x's into the numerator. So we can multiply by 1 minus 3x on both sides of this equation. And we get 1 minus 3x times y is equal to 2 plus 4x. Now we want to start moving all of the x's to one side and everything without an x over to the other side. We can do that by first using the distributive property on the left. So this is y, 1 times y is y, minus 3x times y. And this is equal to 2 plus 4x. Now let's move, again, we want to move everything with an x over to one side and everything without an x over to the other side. So we already have a y on the left, so that's a term without an x. So let's move everything without an x over to the left. So we can do that by subtracting 2 on both sides. So this is y minus 2 now over on the left. We want to move everything with an x over to the right side. We already had a 4x over there. So we need to add 3xy to both sides now. And that moves this 3xy over to the right. So we get y minus 2 is equal to 4x plus 3xy. Again, what are we trying to do? We're trying to solve for x. And to do that, we need all x's on the same side. We have that now. So we can continue with this. And we're trying to solve for x. So we want to get just an x by itself. Well, we can do that by factoring out an x out of each of these terms. We notice there's an x in 4x, and there's also an x in 3x plus y. So we can factor out that x. When we factor what's remaining, well, what's remaining is 4x divided by x, so that's 4, plus 3x plus y divided by x, that is a 3y. And now on the right side, we have x times 4 plus 3y. So finally, we get y minus 2. To solve for x over on the right, we need to divide by 4 plus 3y. So we get y minus 2 divided by 4 plus 3y is equal to x. But we're not quite done. We have one simple thing to do to finish this problem off, and that is to swap the x's and y's back. So we really get y is equal to x minus 2 over 4 plus 3x. So again, just everywhere we see a y, we write an x, and everywhere we saw an x, we wrote a y. And that is our inverse function. So again, we started with y is equal to 2 plus 4x over 1 minus 3x. And the inverse of that is y is equal to x minus 2 over 4 plus 3x.